Okay, so now that you have the repo, we're gonna actually not start here because this is later. I actually have a little presentation before that, which you can see because I need to change which screen I'm sharing. Okay, cool. Let me try to do. Can I do presenter view and get away with it? No, I can't. It's okay. All right. So, hello everybody. I never introduced myself. My name's Taqiya. I am a second year PhD student. I in ECE and I work primarily with Professor Ortiz, but I'm also a part of Socrates. And what I'm going to show you is something that Himali and I worked on for one of our Socrates classes last semester. It won't go too much in depth into the robotics part of it. The way that I designed this kind of workshop is for it to be a little bit more hands-on. I'll give you like some background information. So if you want to learn more, you can always go and learn more about how the architectures work and everything. But this specific workshop will be a little bit more hands-on. Yes. So now that, okay, so let's start. So we're going to work with YOLO and OC sort for object detection and tracking. So a little bit motivating what, so okay, so this is the agenda today, right? So the first thing we're going to do is it's going to be a YOLO V8 version 8 overview and a hands-on demo. Second part is going to be YOLO V8 with OC sort, which is the detection and tracking, which is the tracking algorithm. And the third one will be a little, I say challenge, it's more like you to try to tweak the code and do something on your own. Hopefully we can get to the end. Okay, so to kind of motivate it, what is object detection? Object detection is like identifying anything that's within a given visual, which can be an image or a video. You're not only identifying objects, you're drawing bounding boxes around it. And there's like wide range of applications, as you can already imagine. Um, you know, Google uses object detection all the time to do facial recognition and to group pictures of your friends together, right? And in the past, it was done using, hey, are you here for N2E? Yeah. We're just starting, so have a seat. Um, sorry. So in the past, it was there were like shallower, not deep learning models like the LSTM and support vector machines that were used. But now, because of how advanced technology has become, we use deep learning techniques and even transformers, if you're aware of those, to do object detection. What we're going to use today is something called YOLO, which is a deep learning technique. Okay. Now, there are different challenges with object detection, right? Of course, an image is just two-dimensional, right? You're only giving the two-dimensional information to your model. In the real world, everything is three-dimensional. So if you change the variation of the camera, the model will learn different things, right? So the viewpoint variation can create different ideas within the model. Occlusion lighting, what lighting, we care about lighting when we're taking pictures for Instagram. It's the same idea with models because you need to make sure that the model is actually able to see all the objects within it in proper lighting, so that they can identify the features. Object variation. So again, this comes from viewpoint variation, right? So 2D versus 3D, if they can see the depth of the object, if they're just seeing a frontal, in an egocentric view where it looks just two-dimensional. Deformation. If there's too much clutter in the background, often if there's a lot of people in a frame, even the best models are unable to identify every single face or even group like box out every single face as a human face because of how cluttered everything is. So even they get confused. And of course, speed with any deep learning model, speed is a challenge because these are heavy models with a lot of parameters. Given these challenges, something that kind of revolutionized how we do object detection today was what we're going to talk about, which is YOLO, which stands for You Only Look Once. It came out way back in 2015. It's a real-time object detection model, and version 1 was, as I said, came out in 2015. I've linked the paper here if anybody wants to go and read it. I won't go too deep into everything. The great thing about YOLO was not only was it accurate, it was also very fast. So you could feed a video and almost in real time, you could get the detections with good accuracy. As you can see, this person's moving their fingers, and YOLO is very good at detecting what the letter is, right? Based on sign language. So that's like one of the great things about YOLO. It used something called the convolutional neural network. Have you heard about CNNs? Little bit, not really. CNNs. Yeah, PhD people will probably have heard about CNNs at this point. CNNs is like the holy grail of computer vision. I'll okay, before I'll talk about it a little bit, but before, this is an overview of how YOLO V1 works. What it does is basically it makes an image into different grids. And based on your kernel size or in your window size, which is, and kernels are the key to CNNs, it will take a single segment of the grid and try to identify objects within it. Okay? It'll try to identify objects from every class that it's been trained on. And as you can see, when it does that, there are multiple bounding boxes, and there can be multiple bounding boxes for the same object just because of the overlapping of these grids. And then there's a process called non-max suppression, which is a post-processing that happens that only takes the bounding boxes with the highest confidence, discards the redundant ones, and then looks at the overlap and suppresses everything else to give you these clean, like singular bounding boxes. If that makes sense. Does that make a little bit of sense? That's essentially how YOLO works, okay? Yeah, so this is just, again, as I said, non-max suppression. So it resizes, meaning it makes the image smaller, compressed, or whatever the kernel size is. And then it goes over it slides over all the grids. Like this one is the kernel, and it's sliding over all the grids and getting more and more information. And that's the convolutional network that's running. And then at the end, it does non-max suppression to give you these clean bounding blocks, essentially. First version of YOLO had only about 41,000 parameters. I want you to remember that number because you're going to see why. This is the architecture of the first version. It's very simple. If I show you the architecture of the version 8, you'll see how it's developed. The picture is not here, so you're not going to see it. But if you ever Google it, there's like, it's so much better, and there's so many more parts now. But this is the simple architecture. As you can see, there's many convolutional layers. So each of these layers will do the kernel mapping thing multiple times to increase the accuracy with which they're detecting the bounding boxes. And at the very end, these are the fully connected layers. So at this end is where they do the non-max suppression to get the singular bounding box and then map that bounding box to a class. This is basically a multi-layer perceptron, if you know what that is. It's like a fully connected layer. It's just object classification at that point. I'm not going to go into details because that's unnecessary right now. If you want to learn more, there's papers and resources out there for you to like go and look at. Okay, now the number I told you to remember, 41,000. 41,000. YOLO version 8, the smallest model, has 3.2 million parameters, which should tell you how much bigger it is now. And this is not even the current one, this is 2023. Version 11 exists as we speak in 2025. So YOLO is getting better and better. And one of the great things about YOLO is that it keeps developing more, it becomes more user-friendly as it goes. Among the key features, you don't need to look at these, is this quick implementation on a command line and Python IDE. So now, unless you're even training or fine-tuning YOLO V8 on your own data set can be done just one command line input on your terminal. It's that straightforward. Despite being bigger, these models have also become faster. They do things like decoupling the head, something called a C2F module. I'm not going to go into it. That not only makes it more precise, but also faster, despite the parameters increasing. So yeah, that's the cool thing about YOLO. Any questions so far? That was a lot of information and not a lot of specific information because I don't want to give you specific information right now. If you want specific information, I'll be happy to give you papers later on that you can read or blog posts you can read to get more information. This is just to motivate what we're about to do. What we're about to do now is a demo. This is where we use our Python notebook. So does everybody have the files downloaded on your computer? Okay. if you, oh, this is, you can't see this. Okay. Okay. So if you have the files downloaded on your computer, um, follow the README. So follow from step 3, okay? And create this virtual environment, okay? So you just do Python mven venv. No need to make the directories or anything because you already have that. And make this virtual environment and then download the requirements file. Does anybody need help with that, or do you guys know how to do this? Okay. Is yours working?
I think it's. I think we start with computer. In the background.
So if you go to the default, just download it. Does anybody want to work with them? David?
David. So I was trying my best to show you certain a little bit. Such that do you select?
Into the pick and store. Oh yeah, you're done.
I didn't. I didn't do that. I'm just gonna try my best to show you.
Wait, what computer do you use? Oh, then can he work with you? Yeah, because she has a, that might be this year.
Maybe, yeah, never.
And then.
Yeah, I was gonna say maybe we could swap, because maybe it'll help out Ryan, but because Ryan's also.
Did you accept your as well?
No.
I will.
Sure also.
Yeah, or do any of you? Are you okay sharing with him? Like sharing, like just so he can follow along. Okay, open this both. All of it. So open this. Okay.
It's on the GitHub, it's on the flyer.
Almost. So for people who haven't made virtual environments before, why we do this is so as not to break our computers. Himali and I have firsthand experience as to what happens when you start a project without making a virtual environment, because some projects and specific packages require specific versions of other packages, and you want them all to be compatible, and you want to put it in a box and only use that box when you're working on this specific project. That's what happens when you make virtual environments. If you don't do that and you download everything to your base environment, what will happen is there will be multiple conflicts between packages. One project will require Python 3.12, one will require Python 3.9, and there will be a clashing of heads, which will break your computer, not literally, figuratively. And we don't want that. So pro tip, whatever project you do, create a virtual environment for it and name it as such. Oh. Okay, I think I know what happened. So yeah, can I have it?
You guys install Python on Windows or apps?
That's fine. Just like
select this. And then copy that into here and then
This one.
activate our requirements to text.
That's so great.
Oh, no, one back, just if I don't have. Just copy it right now. Batch is doing the traffic. It's through the next one. But you're not. So don't worry. No, 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 no. Now we're gonna do.
Yeah, for some reason I don't.
Oh,
I think that works. Yeah.
actually, I'll do two.
This is it.
Another time. Did it work? Yeah, yeah, it's just a folder. I'll have to change it again.
So I think.
Oh,
Said, do you want to create a folder or something? You said yes,
You want it?
but then.
Well, activate it. Really waiting for this. You guys are good? Well, you're you guys. Well, you're using. Well, I think it's the folder issue, right?
Like your environment.
Great, I'm glad you have plenty of your business because I use Windows.
Yeah.
Very good, okay. You're ready. Oh, okay. So once you guys have the requirements.txt downloaded, open the IPyNB, the Python notebook, and look at this. Make sure it's set to the correct environment. Select the correct, so because you need the correct kernel. Yeah, existing Python. It go to the Python environment. Yes, correct. Correct. Yeah. So if you click on the top right that says select Python or kernel, you can select the one you just created. So kernel is just the environment it'll run in. So once you're ready for that, it's sorry, Python environment.
Should have the one.
Yeah, it's called Yellow. We have a math person here.
Yeah.
Can you help me download Python on his PS4? I don't know. Okay, here's
And try to get yes, I think what size is download.
Python.
Like,
But you use, yeah, that's what I was gonna say, you definitely do, so it shouldn't be an issue. Okay, try that, open up. I'm trying to go. Yes, if it doesn't work, reboot. Reboot. Okay, does more or less people have Python, not Python, the virtual environment set up and the Python notebook kernel selected? More or less? Okay. For the sake of time, I'm gonna kind of go through. Okay, so I won't go through every cell because it's just like trivial stuff. So these are all the libraries you'll need. Um, so yeah, I hope it runs for everybody. So just try to run it. This is the Python model. This was the base or the smallest model that we showed with 3.2 million parameters. Because YOLO is now open source, you can just import it as a package like NumPy. So it's very convenient. And we can just import, like name the whatever the model we want to use and just download the pre-trained weights. So we're going to do that. And then we're going to load the image. You should all have the image because it was in the repo. And then what we're going to do is, you see the model here is the one that we downloaded here. And we're going to pass the image. And the results is usually like a long list of different information. We're just going to get the first piece of information and show that. Please work. There we go. So this is ideal. Oh, you can't see this. Okay. This is ideally what you should see when you download your when you run the the image through the model. So this, as you can see, is basically object detection, right? So it's not great because we selected a rather cluttered image, but it does a decent job at identifying the people that are in front of it, right? So see, it identifies this person, this person, this person. Sir Henry is not identified because he's not a person. So, and what you see on this side are confidence scores, essentially, right? Of how confident the model is that this is a person. I selected this because it was Rutgers themed. You can put any image into it, and it'll be able to pretty well detect the objects. Have you been able to run this? Did you get an error? Oh, so, oh, but you can't run this in the Jupyter Notebook. Oh, I don't think this would run together. Sure, have you done it before? Okay.
yeah. That's all.
Yeah, run until you get that. So run until you get that. That'll be when you run the image.
You guys run?
Are you still struggling with the virtual genre?
Hmm? Yeah. Yeah.
The real issue for
I think it's an issue, but you can say that it's
I don't know if both will run together. Try to delete this, because you can't pip install requirements here. You're trying to put it in your environment that the notebook is running in. So delete this list. Yeah, just delete it. Let's stop it. Forget about it. And then here, wait, so go to your terminal. It ran, right? This one? Try running this. Yeah, it means it's a. Oh. Oh, there we go. See? Oh, okay, yeah, now you download the model. I need the terminal. So one more thing that I do want to show here is you can see how many objects. So they detected 13 objects, right? You can see the speed, you can see how many people there were, how many umbrellas there were, and what have you, okay? And here's also some post-process information, like what the shape of the images were. So it was 320 by 640. There was just one image, so it's just that one. So they basically resize the image, do the detection, give it back to you. And you can also analyze each box, so see the information in each box, right? So this is the first box. You can see what the coordinates of the box are. I've written down here like every information you're gonna get. So XY is just the coordinates, right? So X1, Y1, and X2, Y2. I think that's how they do it. And they give you the height and the width, so you can identify the box. It gives you what the class of the object is, which in this case would, I think, be 1, because that's the human one. So this is, or 0, I guess. Here you go, 0. XY, these are the coordinates, and then this is the confidence score. So the first box with human was 84% confident. And you can see all the boxes. If you click on this, you can see all the boxes and the information for all the objects that were detected. This is cool because it's just an image. We can do better. We can do videos with YOLO now. In the past, we couldn't. When the first model came out, it was just for images. Videos were very slow, but now they can also do videos. How they do videos is the same idea as images. They take every frame as one image and process it at a time. But because of how fast YOLO is now, it happens in real time. So if you run the next block of codes, you'll be able to, there's a video in the repository, so it should load. And then if you run the second one, it will do you can see this, basically, this is where the detection happens. So you're reading the video, cap is open, is just basically reading the video, return frame. So you're reading every frame, right? So so this is a loop. You're reading every frame and you're putting every frame through the model. So every frame is being treated as one image, and you're doing the detection thingy. And at the end, you're writing out each frame. You're stitching back the frames again into the video, but this time with the detection. So that's what it's essentially doing. I'm gonna hope this runs as well. So as you can see, we had only one of these when we ran the image, right? Only one showing the speed, how many people were detected and whatnot. Yeah. But now there's multiple, because one for every frame, because every frame is an image. And this will run however long it takes to run.
if it was a lesson.
Okay. So once it finishes running, you should have a video in your repository called YOLO V8 output, I believe. Is that what I named it? Let me take a look. You won't be able to view it on VS Code, but we can view it. Let me see what I named this thing.
And this is just running.
Yes, you will have something called output video.mp4, which let me look.
This is just solid.
Here. So this, as you can see, same idea. You see the different bounding boxes and you see you can't read it because it's very small. But the person and the confidence. And this does it in real time, right? If we play the video again. So it does it in real time. It identifies the girl and the bicycle and the people sitting here and the people walking by. Okay, so did all that make sense? I know we're having technical difficulties with the Python stuff, but any questions about this so far? Made sense? It's very simple and it's all off the shelf. So it's not much coding that has to be done. You just have to collect the model, put it in put the image in and or the video. You can also do it with your webcams, by the way. If you change the video feed to your webcam, it will do it in real time.
Actually, it's
With the webcam? No, it isn't much though. No, it's not much. I haven't done it. No, I didn't have time to do it. I wanted to do it, but I did not have time. Anyways, please, all of this was made in an hour. Anyways, so that was that, and that's all cool. But now that you've done it on a video, you can see how the boxes are very glitchy because of the frame rate and video being moving objects. It's a little hard to keep the boxes static and stable because like in an image where it's sure, okay, this one box is one object. In a video, that's a little challenging, but that's what you need for tracking. Now let's talk about tracking. So I'm going to switch back to my slides. Okay, let's talk about object tracking and why we care about it. So object tracking, it's literally what it sounds like. It's basically tracking one object through multiple frames in a video stream, okay? But there are multiple challenges, some of which we just talked about, how these people or these objects are constantly moving and okay. I was like, what just happened? I was like, who? Ghost. As a result, there is certain blur that happens because of this motion. There are occlusions. People walk side by side and you can only see one person and half of the other person. People move fast. People start running. People start jumping and squatting in the middle of walking because they want to. Those confuse the model. And it's hard for YOLO to keep static boxes and stay the same and stable throughout the stream with just YOLO on its own, okay? So the other thing is tracking essentially also means you want to make sure this object is always in frame. So you need a way to identify uniquely an object and let the model know that notify me when this object leaves. But the model needs to know that this is a unique object you care about. That's tracking. YOLO doesn't necessarily do that. It just identifies and tries to keep the box, but it moves, it shifts. It may use a different box with a different confidence level. We don't want that when we are trying to track something. We want to make sure it stays the same box and the same ID so that we can ensure that this object is in my video stream the whole time. And there are various applications of this. One of them is robotics because a lot of robots have to monitor people, movement of cars, movement of a specific car, the person they're trying to navigate to a specific place, right? And in order to do that, and there's obviously other things like, of course, self-driven cars is like the most obvious one. Surveillance, sports analytics, you want to track constantly how a player is moving to analyze how their like game plan is, okay? To beat them, basically. Drones, healthcare, what have you. You need it for different reasons, but as you can see, just object detection model like YOLO on its own can't really do that efficiently. So we add another layer to YOLO or supplement YOLO using something called OC sort or observation-centric sort. This is a tracking algorithm. What it does is it is designed to handle objects while they're going through occlusion and motion discontinuity. So all the things that YOLO finds challenging, this kind of makes up for it. How it does that is using something called a Kalman filter. Do we know what Kalman filters are? Okay. So Kalman filters, in very basic terms, is a way to predict and update an object state through different frames, right? So you're going to see it in the code. What it does is you will initiate a matrix, okay, that contains different information about an object, okay? This information can be, actually will be, your bounding box coordinates, the height and width of the coordinate, maybe the confidence level of the coordinate, and also the velocity of the coordinate. What the Kalman filter will do is two things. First, it will try to predict what this object's next step is going to be in the next frame based on information it has previously. How does it accumulate the information? Through the method of update. Update will keep track of the object's velocity through the previous frames. Okay, and based on that, it will simultaneously predict the next one, as well as based on the prediction and actual what happens, it will also update its weights to ensure that the predictions get better every time. And by doing so, it will be able to track the object across multiple frames. That's like the very basic concept of Kalman filters. Of course, there's more nuance to it that I'm not going to go into. But did that make sense? Vaguely? Okay. So Kalman filters are used, and one thing that Kalman filters does, and we kind of tried to enhance when we were applying it to our robot, was re-identification. So as I mentioned, because of occlusion or just moving out of frame, a lot of the times, if you say assign an ID to an object, because of moving out of frame or occlusion, the detection model isn't able to identify the object anymore. What will happen is it will, when the object comes back in frame, it'll assign it a different ID, but that kind of defeats the purpose because we want to make sure this person or this object is always in frame and is the same one. So that's where you need to do re-identification so that the same ID is assigned to this person or this object when it comes back to frame. Kalman filter does this rudimentarily. It does, so a part of that state matrix can also be features, which it also updates through different frames. And when a person or when an object moves out of frame and comes back, it does the feature mapping and assigns the same ID if the features match. We tried to enhance it a little bit when we were doing our project because it was a little bit more sensitive. But that's something that Kalman filters also does, and then you can tweak the parameters. So the key features, again, of OC sort are it handles occlusions better than traditional sort algorithm. It has improved motion prediction. Again, if a person starts jumping and then starts walking again, you want to make sure that the bounding box stays stable and identifies this as the same person throughout the different frames. It's a little hard if you don't adapt your code and your sorting algorithm to be robust to these kinds of motions. OC sort is actually good at that, and you can further enhance it by tweaking the parameters, as I said. And the third and most important thing is, again, like YOLO, it's light enough that it would run on your personal computers because, like, if you think about it, these are very like complicated algorithms, but you can get this off the shelf, like, and it's good enough that it can do it in real time, but also be computationally light enough for you to operate on your machine. Did that make sense? Any questions so far? How are we doing on time? Oh, we don't have a lot of time, do we? That's okay. We're almost done. Okay, now we're gonna go back to the code. Okay. Okay. So can everybody see this part 2 of the demo? So this is where we implement OC sort. So OC sort, unfortunately, is not something like YOLO, which you can just get off the shelf. So you know how with YOLO, we did import YOLO, and then we did YOLO equals to model YOLO v8 dot or whatever and dot pt. OC sort is a little bit more complicated. What OC sort does, it gives you like a skeleton code that you can use to implement and then change, which is what the helper functions and backend code is. I will not walk you through all of it because I personally did not write all of it myself because some of it was available online. So I just took it from there. I'll give you the basic idea because at the end of the day, you don't need to understand all of it. What you need to understand is what to tweak to get it to do what you want it to do. So again, first import the library. You need to import some more libraries. So I'll just talk about this a little bit. So you can see Kalman filter is a class that you can download and then update, edit a little bit more. Cosine is a similarity metric. So cosine similarity is used to update the Kalman filter weights as well as to do the feature matching that I had spoken about. It's a similarity matrix, no, similarity metric. Have you heard about cosine similarity? Yeah, a lot of you have, and you will. It's like Manhattan distance, so L1 distance. So you just take the absolute value of the difference of two variables to see how similar they are, how far they are. Cosine similarity is also one such thing. You take the cosine of the two vectors, basically. That's what that is. HOG is a feature technique. The way that HOG works is it again takes like small sections of your image and tries to detect edges based on the color variations and the different edges within, and then for every segment it takes all the different types of edges and creates a vector which it uses as its feature vector, because essentially every object or every image will have different feature vectors because it will have edges at different places or light variations at different or color variations at different places. Did that vaguely make some sense? Okay, so that's like the high level overview. You can read the code later on. There's a lot of I left a lot of comments for you to if you really want to understand and get into it. I'm not going to go through all of this because it'll take a lot of time. So yeah, just run it for now. Oh, and then this little thing is called IOU, intersection over union, is how is to see how the boxes overlap, okay, to find that common intersection, which would essentially be your object. So that's IOU. Again, here, this is the similarity. We use cosine, as you can see, cosine similarity for that. This is just to color the different boxes in different ways. So this is not important. Kalman filter, I put comments here for you to see and read later on. I'm not going to go too much into it. This is the transition matrix. So this is the one that encodes, as you can see, all the information that we talked about. So this is the distance or the coordinates, width, height. These are the displacements and the change in width. And then, as I mentioned, there are two functions that are important. The update, which usually that updates your transition matrix with what you just learned, and then there is predict that predicts what the next transition matrix could be. Yes, and then get state is just the transition matrix. Okay. Okay, this is the little fun part. This is the OC sort class. And all of these are parameters that you can change according to what you wanted to do. I left like comments on each of them for you to like change if you would like. Here's all the parameters. These are all the hyperparameters or like, or not hyperparameters, what's it called? Arguments that you can put when you're initiating the OC sort tracker. And these are things you will put in to your code depending on what you're trying to track. So you'll change different things. So right now, detection confidence threshold here is only 0.3, which is like very low. So you might need to change that. You might want to change. So how many frames of history? So the feature extraction that I talked about, if a person moves out of frame and comes back to frame, how long can the person be gone till I assign its ID to someone else, till I forget about its features? That's one thing, which is called the cooldown. And this one, which is maximum frames of history, is how many of the previous frames features should I keep for this person at every time? Because there's a buffer that is updated every frame with new features. And then when the person goes away and comes back, this buffer is used to re-identify that person. So how long should my buffer be? So these are, again, are parameters you can change. The names are pretty self-explanatory and you can always play around with it. Again, this has an update to update the features and also the trajectories. And there's a lot of helper code that I'm not going to go over it. There's a lot of comments in the code, so if you want to ever go over it, you can. what we're gonna do is here initialize the tracker. This is simple again here. See, you can change the parameters how you want. And okay, then we're gonna load the video again. This is the information on the video. You can see the frames per second. And this gets important because you would want your output to be the same frames per second. So this becomes a little important. Okay, now this is the fun part. If you look at it, it's pretty similar, okay? So it's the same as it was last time. You're taking every frame and putting it through your YOLO model, right? And you're detecting the bounding boxes. Only difference is this time you're also updating. You're getting the features because we wanna have a feature buffer. And what you're doing is you're updating the tracker as well. This is the only thing that's different from the previous code for YOLO that we did, where you're updating the tracker every time with the new detections and the features, so it's able to do its thing and maintain the ID and assign the ID if necessary. So if we run this now, you will get a video output called OC sort something called OC sort output video. If it finishes, yeah, once it finishes running, it's the same thing. We just have this extra layer of tracker that is making sure that instead of having person 84, we have an actual ID to make sure it's the same person across the frames and not different people. Okay, once it stops running. Right. So here. So this is what you would get. As you can see there is an ID number now, and that stays. See for example, okay, now it left, but it stayed for a little bit. So because you would have to tweak the parameters, and this is not custom made for this video. I just did it randomly to show you. But for example, you see the girl, it stays ID2 for a while, the bike. It stays ID2, right? And then the amount of time that these people were in front of the bike, the occlusion, it exceeded how long the ID would be reserved, which is why it was assigned to this girl again. So these kinds of things, you would need to fine tune with the parameter settings. You would need to play around with it, see what works. The project that we did for Socrates was for a campus navigation robot. So we tried to make it robust to random movements like jumping and squatting or different exercise movements, just because people do random things on a campus. And we actually got it to work pretty well, even with occlusions and stuff, that if a person moves out of frame or is occluded from frame for a little bit and comes back, they're re-identified with the same ID. So did this work for everybody? Were you able to make it work? No, Vinny? What's the error? What's the error? Can I see? Oh, the that. Oh. Oh, did you run those yourself? Yeah, go up. Go up. Did you run this code? No, go up. Go up. Oh, this is. Oh, here, it should be good. Our workshop. Here we go. Okay. Run all of this. No, go step by step so you can actually see what's happening. Yes, yes, yes. Did yours work? Did yours work? Cool. Did yours work? No? Oh, we can't get. It was scikit-learn, SKI image.
Executive dash image.
I think so. Let me go. I don't remember what the thing was.
Yeah.
Yeah, scikit image. Scikit dash image, yeah. Okay. Um, were there any questions so far? This was the end of the lecture because I don't have any other information to give you. Um, was that clear? Anybody have questions or anything they want to share? Okay. So the last part was supposed to be a little challenge or something for you to like play around. So if you want to do it, like the first one is actually pretty straightforward to do. So just track an object. You can use your own video. You can find, if you can find with the remaining time, if you can find a video of your own and then try to see where you can add a filter, like an if statement essentially to only track a specific class of objects. So only person, only bicycle, only birds. I don't know. So you might have to do a little bit of Googling because you need to find what the class ID is. Humans is 0. I don't know what the others are for YOLO. You have to find that. If you want to have a different video, that's also okay. The stars are difficulty. So these two are the easiest to do because it's pretty straightforward. These are a little challenging, these three. Not impossible, obviously. It might just take a little bit more time. And the last two are a little bit more complicated. So if you want to have a little side project over the weekend, if you're free to use the code and figure out how to do this. But yeah, that was the end of the workshop. And the rest of the time is for you guys to play around with the code and do what you want with it. I'm gonna do is stop my video.